But let's kick this off. This is kind of the cloud and DevOps track, and we're going to be talking about streamlining Java application deployments on Kubernetes with Eclipse JKube. And our speaker is Rohan, right? Rohan Kumar, a software developer from India who's working at Red Hat to try help improve the developer experience on deploying Java applications. Right. Round of applause, please, for our speaker.
Okay. Thanks a lot for attending this session. So let me introduce myself. So I'm Rohan Kumar. I'm a software engineer at Red Hat. So I've been mostly working on improving Java developer experience on top of Kubernetes and Red Hat OpenShift. So I work on these 3 open source projects. They are basically focused on Java and Kubernetes, binding those 2 technologies together. So let me dive right into the problem. So traditionally, as Java developers, we are used to packaging our application into jar war files and then uploading it to some kind of web server. However, with the arrival of container technologies, these technologies allowed us to package our application with all of their dependencies into portable container images. However, in order to convert our application into these container images, we need to provide some kind of configuration file to these tools. But writing those configuration files can be really hard, especially when your application grows over time. And when we are talking about container technology, we certainly can't skip Kubernetes. So Kubernetes is one of the most popular open source projects on GitHub right now. And it provides really powerful orchestration capabilities for containers. But Kubernetes has very steep learning curve, and often you need additional tools, and you need certain domain knowledge of Kubernetes as well in order to work with it. So we Java developers are used to bundling our application classes into jar or war files using standard build tools like Maven and Gradle. However, with the introduction of container technologies, we have some additional steps now. We need to package it into container images, and in order to do that, we need to write some additional configuration files that are called Dockerfile or container file, whatever you want to call it. And we have to provide this configuration to these tools like Docker or Podman, and we need to containerize it. So here is an example of this configuration file that's required by these tools. I'll just give you a brief overview. So you can see that there are certain keywords for specifying various aspects, like how to provide the base system, and what ports to expose, what files to copy, and how to start it. Very basic stuff. But this may look very simple at the moment, but this is for a very simple application. As the application is going to grow in size, these files can get really complex. So deploying to Kubernetes is slightly more involved, as you need to write some additional configuration files specific to Kubernetes. That's in form of YAML, and you also need to work with some additional tools like Helm to package those YAML files into a Helm chart and then deploy it to Kubernetes. Okay, so let me give you a very quick overview about the Kubernetes concepts. So Kubernetes has a really declarative syntax for specifying various attributes. It exposes the various aspects of deployment in form of various resources, like pod or but we don't directly use pod. Deployment is one of the most famous Kubernetes resources for deploying the applications. Service is also one of the resources that's used for exposing the applications to internal or external traffic. Config map is one of those resources to store the application data, non-sensitive data, and secret is for storing the sensitive data like API keys or pool secrets. So we developers have been using our build tools to package the applications into jar war files. So why don't we use the same build tools to containerize the applications as well? This is where Eclipse JKube comes in. It's a tool for Java developers to containerize their applications into container images and also to deploy it to Kubernetes. So it helps the Java developers getting started with these container technologies. It's really opinionated in nature, and it's great for prototyping things. Certainly, when you're working with these technologies, you definitely need to know how these works. But when you're starting with these technologies, it can be really overwhelming to work with these technologies. So JKube tries to make this step easier by quickly letting you get started with it. So it tries to simplify things for Kubernetes, like it creates the container images for you, and by inspecting the project dependencies. And it also creates the Kubernetes resource manifests automatically by checking whatever the dependencies you have. And it also provides support for creating the Kubernetes Helm charts by packaging the generated Kubernetes YAML files into a Helm chart. Okay, you can use JKube by, so it's a tool for your build tool, right? So you can add it as a plugin in your project dependencies. If you're a Java developer, you must be familiar with these build tools, Apache, Maven, and Gradle. You can just simply plug these plugins into your project, and you can just get started with it. One of the special features of JKube is that it's really opinionated. It has this thing called zero configuration. You just plug it, and JKube is automatically going to detect what kind of framework you're using, and it's going to generate opinionated container image and manifest for you. Of course, that can be configured as per your requirements. So it's really great for, so we have support for almost all of the popular Java frameworks like Spring, Quarkus, Micronaut, and Eclipse Vertex. And there are many more, but I just listed some popular ones. So here is a diagram for, so it's a combined version of what we saw in the previous slides. So with JKube, you can do all of those container configuration steps with the help of these JKube build actions. So there is an action for building into a container image. There is for pushing it to some registry, and there is the Kubernetes resource action to create the YAML manifests. There is Helm action for packaging it into Helm charts, and basically to simplify the process of containerizing the application. Okay, so I have a recording. It's a very short recording. Could you please make it full screen? So I'll be deploying a really simple application to Kubernetes with the help of JKube. So, okay, so I have in my IntelliJ, and I have developed a really simple to-do list application using a project called Quarkus. It's a popular framework for writing cloud-native applications. I'm going to scroll down, and I'm going to check check whether I have added the plugin. So you can see that I have added the JKube plugin here, Kubernetes Maven plugin, and there is an additional OpenShift Maven plugin as well. But for this talk, we are only going to focus on the Kubernetes Maven plugin. Okay. All right. So let's go ahead and deploy this application to Kubernetes. So I'm going to switch to my terminal now. So I'll be deploying it to Minikube for demonstration, and we'll be checking the status of our Kubernetes cluster with the help of Podman Desktop. It's a tool for developers to see to test the containers in their local environment. It's a CNCF project, so yeah, So I'm going to start by packaging the application into a jar file by using the standard build ambient clean install. So this should build, it's very standard. It's going to build the application classes into a jar file that should be accessible. Yeah, application is packaged into a jar file. Now let's go ahead and package this jar file into a container image using the JKube's build goal. So we are going to do the ambient build. It's going to inspect the project dependencies, and it's going to create an opinionated container image out of it. So it has created the container image. So let's go ahead and inspect it. All right, so you can see that there is a container image that was created 8 seconds ago. Let's quickly go ahead and run it to see whether it's running or not. I'm going to copy the SHA and just run it with Docker. Yeah, we can see the application logs, and we can see the Quarkus logo. Yeah, it seems to be working fine. So without any additional step, we could quickly containerize it and just run the application. Let's go ahead and create the Kubernetes manifest for our application. So for that, I'll be using the Kubernetes resource goal. It's going to inspect the project, and it's going to add whatever is required for deploying this application to Kubernetes. And it has generated it. So let's go back to the IDE and check where it has generated them. It should be in the target folder, and you can see that it has created a deployment. You can see that it has added a lot of stuff, and it's quite opinionated in nature. So it has created all these resources. And it added some additional things as well. It already knew which ports to expose by checking the application properties. Yep. Okay, so let's go ahead and apply these generated resources to our Kubernetes cluster. So let me just adjust my Podman desktop view so that we can see the application is deployed or not. So let's go ahead and apply these using the create a supply action. So it's going to just apply these YAML manifests. Okay, so application seems to be available now. Let's go ahead and access it using, let's try to go ahead, copy the link and access it via browser. Okay, it's available now. So application seems to be running. It's a very basic application. Just I'm going to add some simple to-dos like buy groceries and water plants. Yeah, it's go for walks. Yeah, it seems to be working. So there is also there's a different way to do the same thing by instead of applying the manifest directly. First we are going to undeploy the application as well. Once you are done testing, you can undeploy it using the undeploy goal. We can do the same steps similarly using the Helm approach. We can package the application into Helm chart and then apply it using JKube. So we are going to use the Helm goal for that. So it's going to package the generated Kubernetes manifest into Helm chart. Helm chart is the default packaging format in Kubernetes. So people usually package them into Helm charts and then use it. Yeah. So if you apply this Helm chart using Helm, you should be able to deploy the application. But in JKube, we have a goal for that as well. So we are going to just run the create as Helm install goal, and it's going to apply the Helm chart onto Kubernetes. Yeah, you can see that application is running. So I'm going to do the same thing. Just try to access it. Okay, it seems to be available, and I'm going to just add some more to-dos. Yep. All right. Yeah, that's really important. Okay, so yeah. Okay, so application seems to be running. So this concludes the demo. Could you please minimize it? And all right, so that was pretty much for the presentation. So I know what I just want you to remember of this talk is about JKube. It's a tool to containerize Java applications and deploy them to Kubernetes. It works out of the box for most of the popular Java frameworks, and it's focused on Java developers transitioning to container technologies. If you're interested, you can scan this QR code to reach the project URL. So yeah, that's pretty much it. Thank you for your time.
Nice. Question. Okay. Any questions from the audience on this? I mean, it's amazing to see Eclipse still going strong after 20 years of R&D. I mean, that was back at university almost 25 years ago. Okay. Any questions? JKube deploying over there?
So I have a question regarding, so you used Docker commands over there, right?
Just to access the container image that was created by JKube.
Okay, so instead of that, is it possibility of using Podman as an alternative to Docker? Because
definitely.
Yeah, okay.
So just to mention, JKube does not rely on Docker, or it just needs access to a daemon. We don't rely on any kind of CLI tools for doing all of those things that I showed in the demo.
Okay. Any further questions to the speaker? Wrestling with Java and making progress in moving towards containerized infrastructure. Yeah? Okay, great. Thank you so much for that presentation.
Thank you very much.
Appreciate it.